So for 9.3, we're going to focus on similar triangles. So, let me just start by talking about a similarity theorem. So the first thing we're going to identify is what I call the right triangle similarity theorem. Similarity theorem. And the way this works is, if I have a triangle that looks like this, if, and I'll just say it, I'm not going to have you guys write everything down, but it says if the altitude is drawn to the hypotenuse, of a right triangle, then the two triangles formed are similar and the original triangle to each other. In other words, triangle CBD is similar to triangle ABC. Also, triangle ACD is similar to triangle ABC. And triangle CBD is similar to triangle ACD. So when you look at that, it's not quite drawn to scale, but basically what they're saying is that there's three triangles. There's this triangle from here to here, there's this triangle from here to here, and then the big triangle. All of those triangles are similar, which means they're proportional. So we should be able to do some math with that, right? Okay, so let's do example number 1 so we can kind of take a look, see at what this means. Example number 1, looks like this. So I have a triangle that goes so this is triangle RST, and then from this vertex, if I draw a line that is perpendicular through here, then that is a right triangle. So I have 3 right triangles, and we'll call this U and T. So it says identify the similar triangles. Well, the big triangle RST is a 90-degree triangle. Okay? If this is 90 degrees, then this is also 90 degrees. So RST is similar to triangle TSU. And then the third triangle is similar to RTU. And that is literally it for example number 1.